Very welcome back to my chemistry lessons. Today we're going to see what is meant by valency and oxidation number of an element in a molecule. So valency of an element is the number of hydrogen atoms or any other monovalent element with which each atom of that element combines. So the example here is given is methane. Carbon combined with the 4 hydrogen atoms. So carbon can combine with the 4 hydrogen atoms. So carbon has a valency 4. This happens because of carbon has a 4 electrons in the outermost shell of carbon atom. So those electrons are used for the bond formation with the hydrogen atoms or any other monovalent atoms. So when you look into the electronic configuration of carbon atom, you can see carbon has atomic number 6, so 1s2, 2s2, 2p2. The electronic configuration of carbon atom in excited state, remember, according to Hund's rule. So we can write 1s2, 2s1, 2px1, 2py1, and 2pz1. So these 4 electrons are ready to form bond with the other monovalent atoms. So that can be considered as the valency of carbon is 4. And in some cases, carbon shows different valencies. So in carbon monoxide, for example, carbon monoxide here, carbon shows valency 2. So remember that carbon can show different valencies as well. So next we are going to discuss about oxidation number. Valency and oxidation number seems to be same, but it's not same. But oxidation number of an atom is defined as the oxidation state of that atom in a molecule. It's a state of an atom in a molecule. So this state, oxidation state, is attained by the difference in electron negativities, by which an atom can lose or gain electrons. If an atom gain electrons, it become negative ion, so it may be called as anion. So if an atom lose an electron, that become positive ion called as a cation. So in oxidation number, there is a chance of forming a plus charged ions and negative charged ions. So here we mention or we indicate oxidation number by putting either plus or negative sign with integer. So for example, sodium very easy to remember. Sodium has atomic number 11. So if sodium lose one electron and become an octet electronic configuration Na positive, when sodium become Na positive, that can attain octet electronic configuration, that is more stable. So sodium has always tendency to become Na positive. So that means sodium has an oxidation number +1. So that's why the first group elements generally have oxidation number +1. So another important, there are some points to remember in order to calculate the oxidation number of an element in a molecule or an atom in a molecule. So oxidation number of a free neutral element is taken as a 0. For example, here you can see hydrogen. You can see hydrogen. Hydrogen is a 0. Here you can see hydrogen is a diatomic molecule, and chlorine is a diatomic molecule, so it is taken as 0. So O2 similarly oxygen and O3 also same. Oxidation number is taken as 0. But you can see in some cases the same element shows different oxidation numbers. We can see some examples here. See hydrogen peroxide, OF2. So as per our general assumption, so oxygen always has -2. But in this case, hydrogen peroxide, oxygen shows -1. And in OF2, see, oxygen always -2 generally, but in this case, OF2, oxygen has +2. So there is an assumptions, but that's in OF2, when we compare the electron negativities of oxygen and fluorine, oxygen has a high electron negativity. That's why fluorine always get a negative 1 oxidation number. Hydrogen peroxide, hydrogen always +1, so oxygen have -1. So in order to calculate the oxidation number of a neutral molecule, we add the oxidation number of individual elements and the sum is equal to 0. So for example, in potassium permanganate, KMnO4, potassium, as per this general assumption, and this potassium is the first two, so is a +1. So potassium has a +1, and oxygen generally -2. So there are 4 oxygens. So -2 multiplied by 4, -8, and 1 potassium +1. So -8 plus 1, -7. So we put X for manganese. So X plus +1 plus -8 is equal to 0. So X is equal to +1. So that's the way we calculate the oxidation number of an element in a molecule. So these points is nice to be remembered. Oxidation number of a free or neutral element is 0, and oxidation number of monoatomic. What is a monoatomic ion? For example, sodium positive ion. So generally that will be the charge of that ion. Na positive, the oxidation number is +1. Calcium dipositive, oxidation number is +2. Magnesium dipositive, oxidation number is +2. Aluminium +3, oxidation number is +3. So generally that will be the charge. Will be the oxidation number of that particular ion. And oxidation number group 1, as I said before, +1, and group 2 +2, and halides, chlorine, bromine, iodine -1, and oxygen generally -2, but there is an exceptions. So thank you for watching. God bless.